Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 24th, 2025, so just yesterday. This paper introduces a new reinforcement learning algorithm that aims to solve major stability problems when training very large language models, especially complex ones like mixture of experts models. The paper is titled Group Sequence Policy Optimization, and the implications for model training are quite significant. The core idea is to shift the learning process from individual tokens, or words, to the entire sequence, which fundamentally stabilizes the training. So to really dig into how these methods differ, the authors show a striking comparison. This first bar chart looks at something called the clipping fraction. Now, clipping is a technique used during training to prevent the model's updates from getting too large and unstable. This chart compares the new Group Sequence Policy Optimization, or GSPO, against the older Group Relative Policy Optimization, or GRPO. We can see GSPO clips about 15% of the time, while GRPO clips almost never. What's fascinating is that despite this aggressive clipping, GSPO is actually more stable and performs better. Now, this stability issue becomes even more critical when we look at a specific type of advanced model called a mixture of experts. These models use different specialized subnetworks, or experts, for different tasks. This chart shows the older Group Relative Policy Optimization method trying to train one. The purple line uses a special fix called routing replay, and it stays stable. But the orange line, without that fix, well, it completely collapses. The training reward just tanks. This collapse shows how brittle the old method is, needing this extra workaround just to function. So, where the old method required a special fix just to train these advanced mixture of experts models, the new Group Sequence Policy Optimization handles them natively. In short, by shifting the focus from individual words or tokens to the entire response or sequence, it fundamentally stabilizes the training process. This sequence-level approach not only prevents the model from collapsing, but also makes it learn faster and perform better. This is a really significant step for reinforcement learning. That's all for this week's AI Research Roundup. Thanks for tuning in. I'm Alex.